In these next two examples, we're going to do a little bit more challenging problems that involve solving exponentials with logs. So, like this other one, in order to not use a calculator, we would try and get the bases to match on both sides, but this side is a bunch of 4s and this side's a bunch of 3s. So the only option we have is to use logs to get exponents out of there, because logs don't keep exponents. So we're going to log both sides, and you can log or natural log. I just typically natural log both sides. Would not matter. And then we'll log this side as well. Okay, we do that so this exponent will go in front and this exponent will go in front. And then we'll have kind of some normal looking problems. Now that exponent is this whole exponent times the natural log of 4 equaling this whole exponent times the natural log of 3. Okay, so we're going to distribute this in. So that's going to be x natural log of 4 plus 3 natural log of 4 equaling negative x natural log of 3. All right, and then we have two separate x's that somehow we got to get x by itself. So really one of the best ways to do this is to get your x's on one side, anything without an x on the other side. So this piece is going to come over that way, and this piece is going to come over that way. So when this piece comes over that way, the sign changes. So instead of a negative x, it's going to become a positive x natural log 3. And then this piece's sign will change to a negative 3 natural log 4, because we would be adding this piece over and we would be subtracting that piece over. All right, so now they're not like terms. We can't put them together. However, they both have a common x. That means we can factor it. So we'll factor the x away from both. And then that is just some value. I have no idea what it is, but whatever that value is, it's being multiplied to our variable right now, so that means I can divide it over. All right, so that goes away. You got x all by itself, and x is going to equal whatever that decimal ends up being. Now you got to be careful on how you type this into the calculator. If you have a fraction button on your calculator, I would totally use that because it'll separate everything really nice. If you don't, make sure that you are putting this entire thing in its own set of parentheses. And a lot of times these natural logs will create a parenthesis, so you'll have to close that one, but you'll have to open an original parenthesis, open that one, close it, open that one, close it, and then have another. So just be careful with when you type that in. But you should get negative 1.6737. All right, and then we'll do another one very similar to it, just so you get another kind of a little bit more exposure to it. Same problem, we don't have the same base on each side, so we're going to log both sides. So the natural log of 5 raised to the x plus 2, natural log of 4 to the 1 minus x. The reason we do that again is so these exponents will go in front. So you'd have x plus 2 natural log of 5 equals 1 minus x natural log of 4. We'll distribute this in, distribute that in, so we don't have parentheses, so we can start rearranging everything around. So x natural log of 5 plus 2 natural log of 5 equals natural log of 4 minus x natural log 4. All right, so we distribute that into both pieces, the logs into both. We'll put the x's to one side. So we're going to move that piece this way and this piece this way, so it's going to be x natural log of 5. When we move this one over, you're going to change its sign. And then over here, we're going to be subtracting that piece over. So the natural log of 4 minus 2 natural log of 5. And then they're not like terms. Can't combine them, but you can factor the x out. So this is the same approach every single time you have a more complicated exponent. You want to get x's to one side, so you can factor that out. And then we can divide it. Again, just be careful of plugging it into your calculator. If you have a fraction button, I would definitely be using it. Then it makes it really straightforward, harder to make a mistake on. And then when you plug all that in, you should get a negative 0.6117. Okay, usually that's about as hard as they get for these types of problems, just because of the complexity of now you got to do distribution, pull all the x's together, factor an x out. It's definitely a harder problem. But that is solving a little bit more challenging problems, exponentials involving logs.